Okay, we're starting recording. Okay, review any homework from last Wednesday. The lecture is really, there's a lot to go over today. And man, if I was redesigning this class, I wouldn't put all these subjects in one lecture session because that's a lot. But we'll go over it, and if we have to bleed into next time, that's fine too. But there's a lot of stuff here. We'll do a little on lab work, but we'll make sure we break in time for our quiz, which will be at probably 20 minutes to 10, something like that. I'll give you a good 40 minutes to work on it. Okay. Okay. Having said that, let's look at any problems you had on chapter 4, lesson 7 through 10. Anything at all from anybody?
Yes, I wanted to see number 1 on page 297.
Okay.
I didn't even look in the back, so I just want to make sure I did it right.
Yep. Let's look at it. Share 297, just a minute. Share, boom. Okay, this is the page. Number 1, game has 50 wooden tiles. Players draw tiles to spell words. If 20 of the tiles are marked with vowels, what's the probability of drawing a vowel from the tiles? Well, you've got, I'll go to my whiteboard. Stop sharing, and we'll share. And we'll go here. So you see my whiteboard?
Yes. Yeah.
Okay, so it says you've got 20 vowels, right? Spell vowel. It doesn't look right. I don't know. How do you spell vowels?
VOWELS.
Thank you.
Yeah, you're welcome.
Okay, and there's a total
a 50
is equal to 50, right?
Yeah.
So you just want to know the probability of getting 50 over or 20 vowels out of 50. So,
yeah.
So you do it like this. Probability of getting the vowels is going to be 20 over 50, right?
Yeah.
And you say we want to convert that to a, well, first of all, that's in decimal form, that's equal to 0.4.
And I think they asked if they were to draw another one, what are the chances to get 2?
Oh,
yeah, so what that'd be 19 over 50?
Yeah, yes.
Or yeah.
Well, 19 over 49.
Yeah, perfect. Thank you.
You're welcome. And then you just multiply that times 100, right, to convert it into percent. Don't forget that part, right?
Nope, I didn't. Thank you so much. I appreciate it.
Yeah, no problem.
Any I'm trying not to go to the answers in the back, so.
Yeah. Perfect. Well, good. I mean, yeah, please go to the answer in the back just to get clarification to show that you know what you're doing. But it's not a bad idea to try to get it yourself, obviously, without looking at the answer in the back. That's for sure. But hopefully the answer in the back will help clarify something for you. I mean, that's the whole idea of having it there and to check your work. Anyway, are there any others you want me to go over? Anybody at all?
I think I have 1 or 2 real quick ones as soon as I find them.
Sure, you bet. Anybody else other than Kathy? Okay, so everyone could do all these because because it's a sprinkle of that that's going to be on the quiz. Okay. I mean, I'm not trying to trick you or anything, but you need to know how to do all those. But, you know.
I'm sorry if I'm holding you up.
No, not at all.
Okay, on page 299.
Okay, let me go to 299.
number 9.
Okay. 299. Okay, just a sec here. Share. Boom. Okay, here's 299. Number 9. Okay. Daniel shuffles the cards and asks an audience member to choose and hold 2 cards. If the cards are chosen randomly, what's the chance that both will be marked with a square?
Mhm.
Oh, we're looking at the cards above. I see what we're doing. These little cards up here, well, how many have squares?
6 of them, so that's like 50% right there.
Well, there's, yeah, it's 6 out of 8, right?
Right.
Is that right? Am I missing?
No, 6
No,
out
no,
of 10.
12
No,
out of
6
10.
out of 10.
I'll get it right. Yeah, 6 out of 10.
10.
So what's the probability of getting one of the 6 out of 10?
See, I thought it was 1/5, but it's not.
No, well, okay, they're hold 2 cards. Well, okay, but you're holding 2 of the cards.
Right.
Yeah, you grab
So,
2 at once.
right?
Yeah.
So if you take the first card, let me see. I'm going to do this. If you take the first card, you've got 6 out of 10. That's the first card, right?
Mm-hmm. Oh, I'm sorry, I'm on the wrong problem.
And the second card will be 5 out of 9. I'm not sure I'm doing this right. What's the answer in the back of the book?
It's 1/3.
What is it?
It's 1 out of 3 equals 1/3.
1 out of 3?
Yeah.
Yeah. So wouldn't it be 1/6 times 1/5?
No, that's going to be 1/30th. The first one would be 6 out of 10, right?
Right.
Yeah.
So that's 2/3. And the second, they're just saying it's 1/2 of that. It's 2/6.
But in the back of the book, it says 3/5 times 5/9 equals 15/45 equals 1/3.
Okay, 3/5 times, what was the second fraction?
3/5 times 5/9.
Ah, okay. Because you've already, okay, I understand. So that,
I don't know where they get the 3.
well, they get the 3 at the beginning because that's the same thing as 6/10.
Okay.
That's what it is. And so I'm going to
Oh,
show you on
okay.
the board. I really hadn't looked at that one, but so it's like this. So the first one is 6 out of 10, right?
Mm-hmm.
And that's equal to 3/5, right?
Right.
So that's the first opportunity. The second one, you've already got, you only have 9 to choose from, right?
Yeah.
And what they're saying is if that first one was a square, then you've only got you've got 5 out of 9 left. 5 out of 9 would be the second fraction because you got 5 squares and you've got 9 total. So then you'd multiply them both together.
Yeah.
Right?
Yeah.
Okay, so that's it. When you multiply them together, you're going to get your 1/3, right? Remember when you multiply, you take the numerators, multiply those together, and that's 15. That's on the top. The bottom is 5 times 9, that's 45. Then you can reduce this down. You can divide the numerator and the denominator by 15, and you'll get 1/3.
Okay.
Right?
Right.
Okay. Any other questions?
Okay, on page 305,
Okay.
number 1, or no, number 3, sorry.
305. Number 3. Okay, I'm on 305. You want number 3?
Number 3.
Okay, 5 students in a class have volunteered for a special project. Only 3 can achieve. How many possibilities a group out of 5? So it's going to be it's 5 times 4 times 3 is going to be the answer. You start out with 5, so it's 1 out of, there's, let me see. Possible groupings. Yeah, it's going to be, it's 1 over 5 times 1 over 4 times 1 over 3, or 5 times 4 times 3, because you're trying to get the total possible groupings. So the answer should be 60 in the back.
Oh, I got the answer as 10.
How'd you get 10?
Let me see, 670.
You see what I mean? If you have 5, okay, just like this. You start out with 5, whether call them whatever you want, A, B, C, D, E, 5 different things, or 5 different people, right?
Right.
And so the first opportunity is 1 out of, will be 5. There, you choose 1 out of the 5, and there's 4 left. So the second choice is 1 out of 4. It's 4. The third choice is only 3 left, so it's 1 out of 3. You're just multiplying these together, and you're going to get 60.
Okay, but the book has 10.
The book has 10.
The answer in the book is 10, and I don't know. I didn't understand that.
Oh, well then, okay, I'm sorry. Go back to that.
So what? 6 times 5 times 4 times 3, so it's 360.
I know.
So wouldn't that be B? C? I'm
doing the permutations, not the combinations.
Yeah.
If it was in order, it would be 60.
It says this is a combination
Yeah, it's a
problem.
combination. I'm sorry. Well, I see. I looked at it wrong. It's
Oh, okay.
I did it like a permutation. So we don't care about the order.
Yeah, it says order does not matter.
Right. So let me go back to that previous page. 304. Sorry about that. Share 304. Stop. Share 304. Okay, so
Yeah. What?
both of these are why. Both of these, they're all they're talking about is why is that a combination problem when we're talking about permutations? It doesn't make sense. Let me go. Book. Go here. Spin it. Okay. Here's combinations. I don't see the answer right now, Kathy. I'll have to look at that when I have a little time. I don't know.
Okay.
I don't know why they're even having a combination problem there when it's all permutations. It doesn't make any sense. I just can't see it right now. I'm sorry. Okay.
No, that's fine. I don't get a lot of these anyway.
Yeah, don't any others to clarify. Sorry about that one, but I'll make a note of it. That was on page what again?
See which one was.
I'll figure it out and let you guys know. I promise.
So does that mean you're going to take one of those off the quiz?
No. I've given you ones that I think I know how to do.
No, I know.
Okay.
I had to try.
Yeah, I know you did. I know. So what page is that on, Kathy?
Oh, I lost my page.
If I don't write it down, I won't do it later. I know it's number 3, but
Page 305.
okay, thank you. Okay, I'll make a little sticky note about that, and I promise I'll do it today and I'll get it to you. I'm gonna put it right up there. And okay, so moving on. So can we get to the lecture now, or any more? Okay. Okay. So let's go to the lecture, because there's a lot of stuff here, and to pack it all in one day is challenging. So I did that. Stop sharing. Now share. Okay. Okay. Can you see my screen?
Yes.
Okay. So the whole chapter is on algebraic expressions, basics, and polynomials. There's a lot to pack in one chapter, believe me. The first little section is on understanding signed numbers, and they use the number line to do this, okay? Number line is just a straight line, right? With 0 in the middle, and anything to the left will be negative, anything to the right is positive. This number line will go all the way to negative infinity, and just keep going and going. That's to the left. To the right, all the way to positive infinity. And every number in between. That's the definition of the number line, okay? Anything to the left of 0 is negative. Anything to the right of 0 is positive, okay? Excuse me. And they use the number line to show how to add and subtract signed numbers, okay? Signed numbers means whether they're negative or positive. That's all we're saying there, okay? Example, you've got a 1 plus a negative 4. Well, you're adding a negative. The way I do and I'm going to show you this. I'll show you what I mean. Okay, so I'm going to go. Okay, I'm going to go to my whiteboard. Okay. Share. Okay, here we go. And I'm going to go to a new board. Okay, so if you have an expression like 1 plus, in brackets you have a negative 4, and your answer you want to get the answer, right? We're trying to resolve this as to what this expression is equal to. You can use a number line, and you can also just use the algebraic expression to do this. In this particular case, we're having a 1 plus a negative 4. So if you look in your number line like this, and you've got a number, you've got a line, right? That's your line. And right in the middle is 0. And so if we're saying we're starting out with 1 and say this was, these things are driving me crazy. Sorry, I can't. Lord. Easy way to do this. Okay, some place in here is 0, and I'm just going to put 0. And over here is 1. This is positive on this side, right? We said it's positive going to the right. Right, that's positive. Going to the left is all negative, right? That's 0. This is -1, -2, -3, -4. So if we're starting out with 1, the 1 is over here. This is where you'd start. And we're adding a -4. So you're going back 4, right? It would be like this, going right back to -3. That's how you use the number line, okay? Does that make, I realize it's messy, but does that make sense to everyone? Yes or no?
Yes.
Okay, any other yeses? Do we make? No, 0 is in the middle. If it's positive, it goes to the right. If we're adding, see, this is a plus a negative 4. So that means this, you go from that value where you were and you go to the left because that's negative. So you go back 4 spaces, you end up at negative 3. Yes?
To visually do that, when I was in high school, I used to put -4 + 1, and that made it easier to visualize.
Sure. Okay. And Jessica, that's a good point. You normally that's a good, I was going to sort of come to that. If you take this thing, this plus a -4 is really just a -4. So this thing is just really equal to 1 minus 4, right? That's all it is. That plus a negative, it's really plus 1 times a negative. And remember, do you remember the rules? If you have a positive times a positive, what's a positive times a positive equal to?
Positive.
Positive, right? 2 positives times each other will equal a positive. What if it's a positive and a negative? What will it equal to?
A negative.
A negative, right? And what if it's a negative and a positive? What will it equal to?
Wouldn't it be positive?
No,
Well, both.
no, it's still
both?
negative, right?
Oh yeah, because
right. You're just flipping it. It's the same thing. And then what if you have 2 negatives?
Turns into a positive.
It's a positive. Okay. These rules, you have to know these rules. Okay. Just memorize them. That's all I can say. That there's only 4 different options. Either a positive times a positive, and these are all times. Okay. Positive times a negative is a negative times a positive is a negative, and negative is a positive. Know all these. So if you look at this here, we've got a 1 plus a positive and a negative, right? Because really this thing is the same thing as saying 1 plus 1 times -4, right? So this is a positive 1 times a negative. So it fits in this category right down here. It's negative. So this is going to be equal to like this, right? Because we just use this rule over here on the right-hand side to say what a positive times a negative is. It's a negative. That makes sense?
On the things that you have on the side, the plus and the plus, well, a plus, what helps me is 2 negatives don't make it right, you know,
okay.
As like a kid. So if you have 2 negatives,
okay,
it can't be positive.
Right. Okay. That makes it. 2 strikes against you aren't going to make it positive. In other words, yeah. Sure. You can look however you want to do it, but somehow understand what this is equal to. However it makes sense to you, right? And then when it does make sense to you, apply it in these expressions. And by that I mean if you have a 1 plus a space and a -4 is really it's equal. That's the same thing as 1 plus a 1 times a -4. That there's a hidden 1 in here. There's a hidden 1 in here. So it can be a positive times a negative to make a negative. Does that make sense? As we go through them, but there's a lot to cover in today's lecture, but you have to understand that on the right-hand side there. So please write that down so it makes sense to you. Okay. Okay, I'm going to go on. Okay. Sharing that, go back. Okay. And again, we're just using the number line to come up with the value, right? And this on the second one here, you're starting with -5 and you're adding 4. So you're starting right over here on the left of the 0 sign. And you're going 4 to the right, you're going to end up at -1, right? And that's what the answer is. You showed on a number line or you just did it. Okay. Now look at this one. Here you've got a -2 and you're adding a -3. This is the same thing as saying -2 minus 3, right? Because we said a plus and a negative is a negative. So it'd be -2 minus 3, and that's equal to minus 5. Or you can use the number line concept to figure it out. Start out at -2, then add another -3 to it, and you end up at -5. Okay? That makes sense to everybody?
Yeah.
Okay, you really need to understand this, okay? Look at example 1 down here, adding 15 plus a -25. Again, because it's a plus and a negative, it's going to be a negative. So it's 15 minus 25. Since the numbers have, let's subtract 25 from 15. Oh, I don't know why they're doing it that way, but okay. Sometimes they explain these just a little strange, I think. But you've got a plus 15 and a -25, you're going to end up with a -10. Okay. I'm going to go on to the next page and we'll see if you guys answer some of these. Okay. Let's just look at the practice. Okay, 8 plus a -3. Who wants to tell me what that answer is?
5.
It's plus 5, right? Because it's just 8 take away 3, right? Somebody tell me what number 3 is. 11, a minus 2 is what? Rachel, do you know? Rachel, do you know? What would that one be?
13?
No.
No.
Oh yeah, it would be 13. I'm sorry. Yeah, I was going the wrong way. Yeah, no, exactly. The negative is a positive, right? So it's be like 11 plus 2 is 13. Yeah, perfect. How about number 5? Emily, what about number 5?
Let me see. That'd be +9, wouldn't it?
No. You've got a
No?
-4 and you've got a -5. What's the -5?
Positive.
Oh, it'd be -9, wouldn't it?
No.
No?
Let's look at it again.
No?
You got a -4 and you have a
Negative.
negative. What's that negative?
Positive.
It's a positive, right? So you've got -4 plus 5. What's that equal to? 5. What's that equal to?
-1.
Not -1.
Oh, yeah. What is it then?
I'm gonna go to my whiteboard here.
Yeah, go to your whiteboard. It'd be 13.
Okay, so we had -4. And then what is it's a minus, right?
Mhm.
Something like that.
Yes.
Okay, so the first thing you do is you want to take care of this negative. And what do we say a negative times a negative is?
Positive.
Positive.
It's a positive, right? So it's going to be -4 plus 5, right? We've converted this negative to a plus 5. Now what do we have?
1.
1. Plus 1 is the answer. Does that make sense? Emily, does that make sense?
Yeah, it does.
Okay. Everyone else happy with that? Okay, we're going to do another one. And I'm going to ask somebody else to do it. Okay, what about number 7? That's easy, right? Who wants to take an easy one? Okay, Kathy, 6 minus 9, what would that be?
It would be 3.
And what's the sign?
It would be and
which is bigger?
the 9 is bigger. So it
So
would be +3.
no, not positive, -3.
Okay.
right? Because the sign, the 9 is bigger, so it's got to be, it's going to be -3. If you put that on a number line, you'd go over to the right 6, then you'd go back to the left 9. You'll end up in the negative area.
Okay,
Does that make sense to everybody?
yeah.
I can't, I'm not very good at showing this on this thing because it's just awkward to work with. Just doesn't want to, you got the number line, and this is where I get messed up with it. And this is 0. You start out with +6, right? Say it's over here. And we go back 9, boom. So we're at -3, right? I'm doing this with my mouse, but does that make sense? Went to the right 6, back left to 9, and end up at 3, -3, right? It's not this one up here. It was the other problem. It's 6 minus 9, right? Understood that. And that's equal to -3. Okay, does everyone understand that? Okay, let's look and see what else we got here. Share. Okay, they're just more of the same. The other thing I want to, let's look at a challenging one. I just want to show you how I do a challenging one. So I don't use a number line. Minus 15. I'm looking at number 22, or yeah, 22, which is -23 plus a -11 minus a -15 plus 21. Looks pretty scary, but we just break it down and I'll show you what I mean. This is how I'd like to approach these things. You don't have to do them all on I don't want you doing it on a number line. It's too messy. So we have a problem, and the problem is we've got -23 plus -11, -11, -15 plus 21, right? That's what we're looking at. So what we want to do is we want to resolve these little things here with the plus a -11. What is that really equal to? So let's go down here and do that. The first one, you got -23. So now what's a plus a -11? This is really a +1 times a -11. So it's like a negative times a positive. And what's that equal to? What do we say in our rules? A negative times a positive is what?
Negative.
It's negative, right? So this combination here is a -11, right? I'm reducing this down to this. I'm trying to simplify it, okay? Now we do the same thing with the next term. We've got a negative times a negative. What's a negative times a negative? What did we say that was? Remember our 4 options? You should have these written down. You should definitely, it should be like this. It should be like a positive times a positive. You guys got to commit this to memory, okay? That's a positive. Whoops. That's a positive. And then in this particular case, it's a negative times a negative. What do we say a negative times a negative is?
Positive.
Yeah, it's a positive, right? You just write these down, okay? And then the other two are that negative times a positive, positive times a negative. They're both negatives. So you got 2 positives and 2 negatives out of the 4 combinations. This particular one is the negative times a negative. Kathy just said it was a positive. So we go over here. I have to start this thing over again because it's Not smart enough. Keep track of me. So now it looks like that, right? I'll put a little space here so it makes a little more sense. And then what's the last one's just positive, right? So now we have our 4 terms. And you look at these 4 terms, you see 2 are negative, right? So now the next step is to add the negative together and add the positives together. You've got a negative 23 and a negative 11. What's that equal to? What's 23 plus 11?
34.
34. So it's going to be, and it's negative 34, right? Now you add your positives. 15 and 21. What's 15 and 21?
36.
Perfect. Now you've got a negative 34 and a plus 36. What's the result? This is where you could look at the number line if you wanted to, but that would make more sense maybe. You're going to go to the right 36. You're going to go back 34. What are you going to end up at?
2.
2 plus 2. So that's your answer. We just reduce this all down. I did it by combining the negatives and then combining the positives, then taking the difference. Okay? That's why I want you to do these. The questions on that? Okay, that's what that's all about. So I would just say on the homework, just practice it. Go over and over it so it makes sense to you. Keeping in mind what these rules are, right? Again, write those things down. Then a negative times a positive is a negative. A positive times a negative is a negative, right? 2 positive opportunities, 2 negative opportunities. Okay, stop sharing that. We're going to go on to the next section because there's quite a bit in this section here. In this lesson for today. Okay. Multiplying and dividing signed numbers. Again, signed numbers mean whether it's a negative or positive, right? It's the same rule. Actually, it's a negative times a negative, or a negative divided by a negative is a positive times a negative, or a positive divided by negative is a negative. It's exactly the same rule. So some examples: multiply 4 plus 4 times negative 25. Don't worry, you're going to multiply the numbers together, and then the sign is going to be, since you have a positive and negative, it's a negative, right? Does that make sense? Okay, we'll have the practice on the next page here a little bit, but what about dividing 160 by negative 8? What's the sign going to end up being? The result?
Positive.
It's going to be positive, right? Because you have 2 negatives, okay? Now, if you have a string of negatives and positives, you just multiply them together. You look at example 3. I'm going to put this on the whiteboard. -1, -2, 2. Okay, they're just all multiplied together. So it looks like this. Okay, you can see my board?
Yep.
Okay, so it's -5. The second one is 6. The third one is a -1. The fourth one is a -2. So it looks sort of messy, doesn't it? But it's not that hard, okay? It looks like that. So what you do is you look and you count up the number of negatives. Since there's 3 negatives, it's odd, so it's negative. That's a simple way. You could also say a negative times a positive is a negative times a negative is a positive times a negative is a negative. You end up with a negative, right? But it's just as easy to go through here and just count up your number of negatives. And if it's odd, it's negative. If it's even, it's positive. Because right up here we said, well, if even, it's positive, right? So we're just obeying this rule that we put together up here, right? Does that make sense to everybody? Who's not talking? Let me see. So if I went, I'm looking to see what I've got here. Okay, where is, what happened to Lucero? She dropped off. Lucero, if you can get back on, please get back on, but I don't see you. Rachel, does that make sense? Okay, I saw you nod, so I'll take that as a yes. Okay, thank you. Emily, does that make sense?
Yeah, it does.
Okay, so if you have a negative number of negatives, it's negative. Positive is positive. And Kathy, does that make sense?
Yeah.
Okay. And Jessica?
Yes.
Okay.
Yes, it does.
Okay. Sounds good. Got everybody but Lucero. I don't know where she is, but okay. We'll keep going. Whoops. I don't want to do that. So I want to share and okay, so that's let me go into the next page. 319, just a minute here. Share 319. Share 319. Okay. Okay, so these are the get the right page here. Okay, here's the page. Okay, these are the problems to just what we talked about. Okay, the top one, they want you to use this without using a calculator. So, Emily, look at number one. What's the answer to number one? And what would the sign
20?
be? 20, and it's just positive, right?
Yeah.
Because there's no negatives. Okay. Okay, Jessica, what about number three? Six times eight, you remember your times tables? What's 6 times 6?
36,
36, and then 6 times 7, you add
48.
another 42, and then add one more 6 to 42, and you're up to 42 plus 6 would be what?
48.
48. So 6 times 8 is 48. So what's the sign in this case, Jessica? What's the sign? I can't, yeah, you're on mute, Jessica. I'm sorry. Jessica? You're still on mute. Hello.
Hello. Sorry, it is negative 48.
Thank you very much. Appreciate that.
Sorry about that.
No, it's okay. It's okay. Okay, Rachel, let's look at number 5. You've got a negative 10 times 1. What's the number and what's the sign?
-9.
Well, negative 10, right?
Oh, no.
Right? So it's going to be 1 times 10, right?
Oh, yeah, duh. I forgot.
That's okay. Okay. But you got the sign. That's the important thing of that. So 1 times 10 is 10. Okay, Kathy, let's look at number 6. Okay. What's 9 divided by 3? And what's the sign going to be?
It would be 3 positive.
Very good. Okay, 3 positive. Okay, so Emily, let's look at number 7. 12 divided by negative 4. What's the quotient of that and what's the sign?
-3.
Perfect. Okay, good job. Okay, let's look at Rachel, number 8. Negative 25 divided by 5. What's the quotient and what's the sign?
-5.
Perfect. Okay. Okay, Jessica, this looks like a hard one, but it's not. Okay. Negative 18 divided by negative 9.
That is going to be 2.
Perfect. Positive 2, because you got a negative negative. So you guys know these pretty well. That's good. You understand that. Okay, I think I've done everyone. Well, I've only got 4 of you here, but Emily, one more. What about number 11? 14 divided by -2. What's that?
-7.
Perfect. Okay, you guys are good on these. You use a calculator, it's the same idea. I'm not going to go through that. So we're going to go on to the next page. I think you got that down. That's good. Okay, next one. Okay, now we're in sort of a different subject. We just keep going and going here. Okay, powers and roots. Okay. Okay, you can see my screen. Remember, if you have a superscript, that superscript is the exponent, right? So if you had 2 to the 5th power, how would you rewrite 2 to the 5th power? I've actually rewritten it, but I'm going to share my screen and go over some stuff. Okay. So now we're into exponents. I can't show an exponent on this thing. Yeah, I just can't. But if it, when I go a deal like when I say 2 and I put a little caret, that's called a caret, and I say to the 5th power, this is like 2 to the 5th power, okay? That 5 is an exponent. What's that equal to? That's equal to 2 times 2 times 2, 5 2s basically, right? Like that, right? Not the 20, it's a 2. Right? And so the way to solve these are just take it by chunks. So what I do is, just to make it simple, is I'll take the 2 times 2. I know what that is. That 2 times 2. And so I get 4 times 4 times 2. 4 times 4 is 16. 16 times 2 is, or 16 times 2 is 32. So the 2 to the 5th power is 32. I just group them together to make it simple. Just 2 times 2 is 4, 2 times 2 is 4, and I got 1, 2 left over. Something like that. Let me stop sharing and look at that screen again. Okay. So these are all powers of various numbers. Remember that any number to the 1 power is equal to that number, right? 8 to the 1 power is equal to 8. And also know that if it's any number to the 0 power is equal to 1, right? So if you had a deal like this, first of all, come on. If we had 8 to the 2nd power, that's 8 squared is the same as 8 times 8, right? 8. 8 times 8 is 64. And below that, what if we had 8 to the 1 power?
8.
That's just equal to 8, right? To that number. Now, if we had 8
Yeah.
to the 0 power, make sure you know this. That's always equal to 1. Okay? Any number to the 0 power is equal to 1. So make sure you understand that, right? And then the last concept, if it's, let me see how they do that before I say anything. Okay, so now that if they have a whole number to the negative exponent, we convert this to 1 over that number. So let me see if I can do this to make sense for you. So if you had a deal like this, and we said that, first of all, we said that 4 squared is equal to 16. But what if we said 4 to the negative, 4 to the negative power, -2. What's that equal to? Well, it becomes 1/4 to that power. Realize this is probably clunky. Is that okay? Does that, so this thing is the same thing as 1/4. And it's hard to annotate this on the board here without really being there. So it's 1/4 times over. So this thing ends up being equal to 1/16. It's just the inverse of this. See, the 4 squared is 16. 4 to the -2 is 1/16. Okay, you just, and I could prove it algebraically, but it probably wouldn't make any sense to you. But just remember that if it's, so if I had like 3 to the -2, that would be the same thing as 1/3, where that 3 is to the power like that, which is the same thing as 1/3 times 1/3. Right, this minute. That's equal to 1/9, and I'm going to show you it's the reciprocal of 3 to the squared. 3 to the second power is equal to, we said it was 3 times 3, which is equal to 9. Well, this should be 1/9. Shoot, I can't erase this. This should 1/3 times 1/3 is 1/9. This is not friendly to. This is really 1/9, right? 1/9. My point is this is the reciprocal of this. So 3 squared is 9. 3 to the -2 power is 1/9. Okay. You convert this to a positive, you put it on the bottom, and that's what I've done here. I made it to the square of 2 on the bottom. So it's 1/3 times 1/3 is 1/9. Does that make that you have write that down a number of times so it makes sense to you, okay? There'll be problems like that. Okay, so I'm going to stop sharing that. We're going to go on to the next page. Again, there's a lot of stuff here in one day, and I apologize for that, but if we have to reinforce it next time, I certainly will do that. I want to make sure you get it. Okay, so these are the problems. Excellent. Let me see. Oh yeah. So now, now we use the radical sign. Okay, this is the square root. Okay. The radical is it's the little thing that looks like a divisor sign. And so, so stop sharing, share. Okay, so let me clear this board here. Okay, so looks like this, right? And you had 144 in here. This thing is equal to 144. Again, I'm using my right hand mouse to do this. Times to the 1/2 power to the, which is square root of that. This radical sign means it's the square root of what's inside it. So it looks like this. So how do you get 140? The perfect square of 144 is 12 times 12, right?
Mhm.
So this 144 is equal to 12 times 12. The square root of that just ends up being 12, okay? Because it takes, because it's the root of this. So the root of 144 is 12, 12 times 12. So 12 is the root. So that's how they get the square root. So if you had 49, and I'm using my right hand, I'm sorry. Too bad. That's equal to, I can put it in terms of 49 is 7 times 7, right? That's 7 times 7, just like 12 times 12 is 144, 7 times 7, 49. The square root of that is 7. Does that make sense? I'll show you just another real simple one. What about the square root of 4? What would that be? What's the perfect square for, how do I get 4? Well, it's 2 times 2, right? And so the square root of 2 times 2 is just 2, right? So the square root of 4 is 2, square root of 49 is 7, square root of 144 is 12. Does that make sense? You see the pattern there? What if I had 9? Square root of 9.
3
What-
times 3?
Yep. And so what's the square root of 9 then?
3.
3. That's all I'm trying to show you, okay? This one is 3 times 3. You take the square root off. You can actually do it like this thing. If I squared both sides, I would end up getting 3. I know I won't go into that part, but I just sort of understand this pattern, okay? Okay, I'm going to stop sharing that. And we're going to look at this again. Yeah, and it's got some problems down here, okay? So solve each. Don't use your calculator on these top ones. What's 3 squared? Anybody?
9 times 9?
Well, not 9 times. It would be just 9.
3 times 3. Sorry.
Right, yeah. So it'd be 9, right?
9, right? Yeah.
What about number 2, 4 to the 1 power?
Before?
It'd be
right?
4, yeah. And what about number 3, the square root of 9?
3. 3.
3, right? Yeah, exactly. What about number 4, 25 to the 0 power?
It'd be 1, right?
And it would be 1.
Wouldn't it be
okay?
1?
It'd be 1, yeah. And what about number 6? Rachel, what about number 6? Square root of 49, what would that be?
7.
Yes, exactly. Okay. And Emily, 5 to the 3rd power, what would that be?
That would be 125.
125, exactly. Now, somebody, who wants to answer number 8? 4 to the negative 2.
Wouldn't that be 116?
Perfect. 1 over 16, exactly right. What you did, you said, well, that's equal to 1 over 4 squared. And so that's equal to 1 over 4 times 4, which is 1 over 16. Perfect. Okay, let's do one more. Number 10, who wants to answer that one? The square root of 64.
Wouldn't that be 8?
That would be 8, yeah. So I think you all understand these, right? Now, the next set, you can do it with your calculator. So you should know how to use your calculator to be able to get the square root or the square, right? Do you understand that? if you have a little calculator like see this, like the TI-30X, right? It's a little, it's all this is a little $10 job. It's, it's all it costs, but it's got enough function on there to find the square root and square, right?
You like this one?
Yeah, if you got one like, yeah, whatever, as long as you can find your x squared and your square root symbol on here.
Oh, okay. Yeah,
That's all you got to just to know how to do it. So,
oh, yeah, there we go.
okay, so can everyone, let me see. So take a simple thing. So show me how you'd get the square root of 256 on your calculator. You know, you want to get the square root sign, so it's that little radical. It's usually the second row, and which is not the top row, it's the one behind that. And what you do is you hit the second key, then you hit x squared, and it'll bring up the square root sign. You put in 256, and then hit enter, and you get 16. Did everyone get that? Okay, so Rachel's nodding her head. Emily, do you have that? Okay.
Yeah.
Kathy, do you have that?
No, I have a calculator, but I don't even know how to use it.
Well, is it a TI-30X? What is it?
Yes.
Okay, it's a 30. Yeah, it is. Okay. Well, hey, you've got a little second sign up in the corner, left corner.
Yeah, it says second.
Yeah, so you hit that first.
Okay.
Then go down to your x squared sign. And above that is a little radical. Hit that x squared sign.
Okay.
Okay, now you've got to put in a number. Put 256 in there.
Okay.
And then hit enter. What do you get?
1.04.
No. You should get 16. 1.04.
Yeah, I don't.
Okay, well.
I'll have to practice with it.
Okay. Anyway, yeah. So just practice a little bit, but just take a simple one so you can can figure out the process, right, without getting complicated. Does everyone else use their calculator to do that? Emily, are you okay with that? Emily, are you there? Yeah, I can't hear you. You're on mute. Emily? Yeah, can you do that?
Yeah, I can.
On the calculator? Okay. Rachel, you're okay on the calculator? Jessica, you're okay?
Yep.
Okay, Kathy, you're going to work on it?
Yes, I am.
Yeah, just
I have to.
on that one page, it gives you the it gives you the process steps for that.
Yeah, I'll look it up again.
Okay. So it doesn't have to get any more complicated than that. Just know how to do that.
Okay.
Okay. Okay, I'm going to move on. Here. So now can you see practice 2? Yeah, they're just more of the same kind of things. Yeah, I'm gonna move on because we have more stuff to do here. Yeah, let's move on. Stop sharing. Okay, stop. Okay, scientific notation, different subject. Have any of you done scientific notation in the past?
Yeah, but it was a long time ago.
Okay, well, let's look and see what we're talking about here. Look at the very top. Well, first of all, it talks about powers of 10. You can see 10 to the 1 is 10. We talked about that. 10 to the 2 would be 100. 10 to the 3 would be 1,000. It's just a number of zeros, right? 10 to the 4th would be 4 zeros and so on. When you go negative, 10 to the minus 1 will be 0.1. minus 2, you'd go over 2 digits, minus 3 over 3, minus 4 over 4. Understand that sequence, either going even positive numbers or negative numbers. Okay. Now, down, a number in standard form is like 620,000. And if we were to put that in scientific notation, what you would do, go back to my screen here. Share. Get rid of this thing. Okay, so if we had the number 620,000, and I said convert this to scientific notation, I'll go to my pen here. And so what we want to end up with a whole number and a decimal. In other words, a number from 1 to 9 and a decimal. So we want to end up with 6.2 times 10 to the some power, right? So the idea is to figure out what power this is. This is in scientific notation for this number. So the way you do it, go back to the number. And what you do is you just go from where the number, with a whole number, you go all the way back to it's just one digit. So you go 1, 2, 3, 4, 5. There's 5 spaces you have to go to get 6.2, right? Does that make sense? 1, 2, 3, 4, 5. So the number becomes 6.2 times 10 to the 5th power. So there's a 5 in here. Ooh, that's a 5.
Oh,
so
wow.
This thing, that's all you got to do. So this is written as 6.2 times 10 to the 5th power. Okay, that's the scientific version, scientific notation version of this standard number. Right? Does that make sense? So write that down so you can see it, and we'll do another one. What if I just said 32.5 and I want to convert that to scientific notation? What's it going to look like?
You move the decimal.
Yep. How many spaces?
5.
Not 5. No. You're going to move it 1.
Oh,
Right? I'm going to convert that 32.5 into a number of 3.25.
Okay.
Right? Times 10 to the what? What power? That's the secret, not the secret, but that's the question.
Is that where you put the 5?
Well, no, there's no 5 in this one. Look, it's 32.5. All I've done is I've moved the decimal place over. Here, I just moved it 1 over. I went right over to there. So I get 3.25, right?
Oh, okay.
And so 3.25 times 10, I moved it over 1 to the left. So
And
this
then-
becomes to the 10 to the negative 1.
Okay, interesting.
Or excuse me, 10 to the positive 1. God, get confused here. That's a 1. Let me do this again. All I did was move it over one spot. 3.25.
Oh, so you move it over until there's no more decimal?
Yeah,
Basically?
you move it over until there's only one decimal. It's 3 point something. This
Okay.
number, scientific notation version is there's a 1 to 9 on that first number, and then there's a decimal point. That's the scientific notation version of the number. So it becomes 3 point, and this is pretty sloppy. It's 3.25 times 10 to the 1 power, which is the same thing as this 32.5. Okay, let's do another one here. So make it a little clearer. If I had 201.3, I said, okay, convert that to scientific notation. So first thing I got to do is, again, I'm going to move this 2 places over. So I'm going to end up with a 2, right? 2 point something. I want to get 2.013 times 10 to the something, right? God, I keep losing my carrot. That, see what I'm, so what did I do? I moved it over 2 places to the left. So that means I have to put 10 squared, like that. So the red 2.013 times 10 to the squared is equal to 201.3. They're equal. This is just in scientific notation. Does that make sense?
Little,
A little?
yeah,
Just practice them.
definitely.
Okay, Kathy, does that make sense to you? You got to move the decimal place over and then account for it when you multiply it by the 10 to the something power. It's got to equal to whatever you did as far as
So you
moving the
always
decimal.
want
Pardon?
the decimal at
Yeah.
0.10?
You
Or-
always want the, you want it one spot. Yeah. You want to, like I say, you want to end up with a number that's 1 to 9. And
Oh,
this
okay.
2, okay? Like up
1 to 9.
here, 620,000, we ended up with 6.2. 32.5, we ended up with 3.25. You see the similarity? We all end up with a whole number from 1 to 9.
Okay.
And then decimal, whatever is to the right of that. Then you have to multiply it by the 10 power to whatever, whether it's positive or negative. Let's do a negative one. What if you had 0.15? I say, okay, convert that to scientific notation. Well, the scientific notation version is 1.5 times 10 to the something, right? What is that something? So we have to figure that out. So what you do is you go back to this and you say, well, how do I get 1.5? Well, I get it by moving the decimal 1 place over to the right, right? So I end up with 1.5. When I do that, then I have to take 10 to the minus 1 because I moved it 1 place to the right. All these others, we moved to the left. That's why we had a positive exponent. All these will be negative exponents. So the answer on this one will be 1.5 times 10 to the negative 1. Okay. Does that make sense? We'll do one more with the negative, okay, right here. I'll just keep them right here. So what about 0.00235? Well, we know it's going to look like this. We know it's going to look like 2.45 times 10 to the something, right? You just don't know what this exponent is yet. So how do you do it? You go back, use a different color. So I'm going to go here and I'm going to go 1, 2, 3 places over to get 2.45, right?
Mm-hmm.
So that means this thing has to be -3. Because I went 3 places over to the right.
Okay.
That you understand? This is, try to understand. If you understand this, then it'll all make sense, right?
I'll do that later.
Just like these, that it's the same thing on this. This, you understand this? The same. They're all the same pattern, right? I mean, either moving it to the left or moving it to the right, and each decimal you move over makes an exponent of 1, 2, or 3, right? That's all scientific notation is. That this doesn't get any harder than this, okay? That makes sense?
Yeah, I'm getting there.
Okay. Everyone else? I'm sorry we're going over so much, but it's anyway.
Quite a lot. Yeah.
It is. I know it's a lot. I know. And anyway, yeah. But we'll get it, and I'll be patient. I'll answer questions. If you have any issues when you start doing the homework, send me an email, please, and I'll respond. I'm very good at responding. I'll respond within a couple hours usually. I check on my phone. I check the emails all the time. I'm always checking emails. So don't feel bad about bugging me at all, okay? if you want a time to get together, like today, I'm open till noon, because I don't have it 11 o'clock. So I'm here in my den, my virtual office here that can just bug me and we'll go over this stuff, okay? Because I really want you to understand it. Okay, I'm going to stop sharing that and go back to this. That's pretty well what we're doing on. I'm going to go on to the next page. Share. Okay, stop sharing, share. Okay, and these are just questions of or problems of what we did, right? Look at number 7 up here, and we'll just do it together, okay? Number 7, you've got 0.000. So what you do is you count the number of zeros. You want to end up with 5.8. So you just count over 1, 2, 3, 4, 5, 6, 7. So the answer is this is going to be 5.8 times 10 to the minus 7. Okay. See how I did that?
Yeah.
Okay.
So we want to go to 5.8, right?
Yep. You want to go to 5.8, right? Okay. On all these, you want to go to a whole number and then the decimal. Whether you're going to the right or to the left, it's the same process. Like look at number 4. Well, here it's a huge number, so you got to go back. You got to go 3, 6, 7, 8, 9, 10 spaces back. So your final number is going to be 1.43 times 10 to the 10th. Okay, that's all we're doing on these. You're either going to the left, going to the right.
So the first one you gave, that would be a -7.
Yep.
Or is that positive?
No, it's negative.
Okay.
It's negative. Yep.
Want to make sure.
Thank you for asking that. Yep, it's negative. Number 4, this one's going to be positive. Okay.
Okay.
If you're taking a big number and getting it down to a smaller number, it's going to be positive. If you're taking a very small number and you're going to end up with 5.8, it's got to be a negative. You got to multiply it by a negative number.
Right? Okay. Yeah, I like that term.
That makes sense?
Yeah.
Okay, so who wants to do number 1 for me? Can you look at that and tell me what it would be?
Which one?
Number 1?
Wouldn't it be 2.3?
Yep. Times.
To the power of 3?
Mm-hmm. You bet.
Yeah.
Okay, good job. Okay, I'm going to go on to the last subject, okay? But that's how you do all these, okay? It's not any more difficult than that. Either going to the left, going to the right. Now, on 10 through 17, you're going the opposite way, right? You're going from scientific notation to standard notation. So it's just the opposite of what we did, right?
Yeah.
Can we do one of those, maybe just to clarify what I mean by the opposite? Let's do number 11, okay? 3.7 times 10 to the 6. We'll do 1. 3.7. Okay, go to my whiteboard again. So that was 3.7 times 10 to the 5th, right? Something like that. I think that was
It's 6.
5th, right?
No, it's 6 on there.
Oh, it's 6. Okay, sorry.
Yeah.
Okay, so the 6 power. So what do? It means we have to move that decimal place to the right, the number to the power. So we got to move it 6 spaces. So first thing, you could just put a whole bunch of zeros like that, and then take your little pencil and go like this and say, oh, okay, I'm going to go 1, 2, 3, 4, 5, 6, right? So that number is going to end up right there. So then what you do is you put it in put spaces around every 3. So you know, so that number is going to be 3,700,000. Does that make sense?
One too many.
I just moved the decimal. So that is going to be equal to 3 Okay?
Oh, because so they're oh, okay, so there's 6 zeros because of
Exactly.
the
Because it's
oh,
10 to the 6th. That's why I had to add it to 3.7. I moved it 6
just
places,
throwing a bunch of zeros.
right?
Oh, that's pretty easy now, I
Yeah,
think.
yeah.
I'll
It's
work on it.
it's just the opposite, right?
Yeah.
You're just doing the opposite. Okay. Okay, I'm going to stop sharing and go to the next section because there's one more little section to go. Let's see. Boom. Okay, order of operations. These are rules that you use to simplify algebraic expressions. They're rules that were agreed upon. So mathematicians could always end up getting the same answer, okay? Because if you don't do things by rules, you can get different answers. So this is a rule. These are rules that you need to follow when you're simplifying algebraic expressions or setting them up. And the rules are, I'll go to the next page on it.
Isn't
Yep.
that the PEMDAS?
Yeah, it's whatever. I never remember those little
Oh yeah, it's like
tricky little
please.
things, but that's exactly
Salad.
what it is. So let me I think let me see if it's on the second page here. Yeah, it's those, that's what it is. Let me see if it even shows it. Oh God, it doesn't, does it?
Parentheses.
Lord. Yeah. What it means is you use your brackets. Okay, I'm gonna stop sharing. I'm gonna share a different screen here. We're gonna bear with me. No, wait a minute. Oh, there it is. So it's one of these. Let me see. No, it's the wrong one. Stop sharing. Oh, just give me a. Bingo. Okay, so here, I'm going to post this on the in Canvas too. Can you all see my screen? Let me make it a little bigger. Oh shoot, it's the wrong one. Tilson, just a minute. Can you see a screen called worksheet number 1?
Yeah.
Okay, perfect. Order of operations?
Yep.
Oh, geez, wait, just a minute. Okay. So here's the order. Do parentheses first, exponents and roots, multiplication, division, working from left to right, and addition, subtraction, working from left to right. So what does that all mean? Here's some examples. If we had an expression, 5 plus 3 squared, right? Plus 3 minus 1, what would you do first? Well, the first thing you do, what you do in parentheses first, you add the 5 to the 3, make it an 8. So now it becomes 8 squared minus 3 times minus 1. And so the second thing you do is you go down to your exponents and roots. In this case, there's an exponent. It becomes 8 to the second power. 8 to the second power is 64. So now it's 64 plus 3 minus 1. The third thing you do is you multiply the 3 times the minus 1. And then the fourth thing you're doing is adding. Okay? So you're doing this based on these rules. This is the order of doing these things. Does that make sense to everyone?
Yeah.
This is what they should have showed on that page. I don't know why they didn't, but they didn't. I'm going to put this in Canvas for you. Okay. These are the rules you have to follow that you use. Okay. And here's a few little examples of how to do that. well, not really how to do it, is to do it. So if you had 18 divided by 10 minus 4 squared, you would take the 10 minus 4 first, right? And get 6, square 36, 18 divided by 36 happens to equal 1 over 2, so it makes it easy. But these are the rules, okay? Parentheses first, even parentheses within parentheses, you do those first. Exponents and roots, multiplication, division, working from left to right, because that makes a difference too. Don't start in your right and go left. Start in your left and go right. Adding and subtracting, start in your left, going right. Okay? I'm going to stop sharing that, and we'll go back to, yeah, that's, no, that's not the last page. Stop sharing. Just a minute, one more deal. Okay, okay, just a sec. Okay. Right here. Okay. So this is the very last page. Oh, that's exactly where I was. Anyway, that's so you use those rules to solve these problems. Work on them. If you have any issues, please give me a shout one way or another. Like look at number 15. There's a bracket within a bracket, right? So you do the inner bracket first, then you do the exponent, and you've got a divisor sign. That's not a hard one, but it's got every part in it. You know, just follow the rules and see if you get the right answer. If you don't, shoot me an email. Okay, with that, we're going to take a 10-minute break and we're going to back and work on the quiz, okay? Apologize for such a long session. But anyway, if I was rewriting this thing, I would make some changes. But anyway, we'll make it all work. So so take a 10-minute break and come on back. And if you have a printer, you can go ahead and download the quiz. If not, you can start taking a look at it too if you want. It doesn't really either one. But anyway, if you want to take a 10-minute break, we'll get back at 9:39. Okay. So I'm going to stop sharing. Okay. And rid of all these things.